Objective 8 on our practice test A, Part 2. We're being asked to calculate the percent composition of a substance from its chemical formula or from experimental data, and remembering to use dimensional analysis in our work. Question 1 reads to us, when a 14.2 gram sample of mercury 2 oxide is decomposed into its elements by heating, 13.2 grams of mercury is obtained. What is the percent composition of our compound? Now in this story problem we're given experimental data, so we will not be using molar mass, not the weight from the chart, but please use the weights that are actually contained in the formula. We have mercury 2 oxide being decomposed. We said decomposition is a breaking down into simpler pieces type of chemical reaction. And again, this is not a balanced equation. That's okay. We get the idea that a decomp means to break down. When we read decomp, I know that I'll be subtracting. They're giving us a 14.2 gram sample of the whole compound, and upon heating it, we break it down into its elements. If we recover 13.2 grams of the element mercury, we can use what's called the law of conservation of mass to determine the missing weight of 1 gram for oxygen. Since we have two elements, we'll need to report out two answers, a percent by mass of mercury and a percent by mass of the oxygen. Mercury contributes 13.2 grams out of the 14.2 gram total mass. Part over whole will be its percent by mass. The oxygen contributes 1 gram out of the 14.2 grams of the HGO compound. Again, part over whole will be its percent by mass. Please hit with me. We'll take 13.2, divide by 14.2, and express that as a percent. I find 93% by mass mercury. And again, hitting to check on the oxygen, part over whole, expressed as a percent, gives us 7% by mass of oxygen. And again, just checking out, 93 and 7 does indeed equal 100% of the weight. Our second problem in our Objective 8, we're to calculate the percent composition of ammonium chloride, a commercial fertilizer. Since this problem does not give us any experimental data, we will use molar masses. We first have to be able to write a formula. Ammonium is our positive polyatomic ion found on our polyatomic ion chart. Here's ammonium. We're going to hook that to chloride, who's a -1. So our formula for ammonium chloride, NH4Cl. We'll have three different answers, a nitrogen, hydrogen, and a chlorine. Nitrogen with its atomic weight of 14, hydrogen with an atomic weight of 1, but I see 4 of them in the formula, and chlorine with an atomic weight of 35.5. Let's sum the elements to get a total formula weight. 14, 4 more, plus 35.5, 53.5. So we'll need to express a percent for nitrogen, for hydrogen, and for our chlorine. Each part over the whole expressed as a percent. There's 14 grams of nitrogen in every 53.5 grams of our total weight of the compound. 53.5 grams will be used in each of these, so I'll go ahead and get that set up. The total weight of 53.5 will be placed under for all three elements. Of the 53.5, 14 are coming from nitrogen, 4 are coming from the hydrogen, and 35.5 are coming from the chlorine. So each part over the whole times 100 for a percent. When I hit for nitrogen, this looks like, I'll say 26.2% by mass nitrogen. 4 divided by 53.5, expressed as a percent, about 7.5% by mass hydrogen. And for chlorine, this one is, we'll say 66.4% by mass chlorine. All right, so 3 individual percentages, one for N, then H, then Cl. One more in this objective. An 8.2 gram piece of magnesium combines completely with 5.4 grams of oxygen. A combination pattern. To combine means to add the weights together. If 8.2 grams of magnesium combines with 5.4 grams of oxygen, the resulting compound will be the sum of the 2 individual pieces. Adding together the weights, we get 13.6 grams of MgO. We'll need to report a percent by mass of magnesium and a percent by mass of oxygen. 2 elements means 2 answers. We'll have 8.2 grams over 13.6 expressed as a percent, and 5.4 over 13.6 expressed as a percent. Let's hit that together. Clearing screen. 8.2, the mass of magnesium, divided by 13.6, expressed as a percent. Mine says, we'll say 60.3% by mass magnesium. And 5.4 over 13.6, expressed as a percent. Let's call that 39.7% by mass oxygen. Again, close to 100% of the total weight is a good sign. We will indeed earn our A+ on Objective 8. Percent composition problems, each element will need its own answer.